Welcome to our deep dive into the key techniques in natural language processing, or NLP. In this video, we'll explore the foundational methods that power everything from chatbots to translation apps. NLP is the bridge between human language and computers, enabling machines to understand, interpret, and generate text in meaningful ways. Whether you're a tech enthusiast or just curious about how your favorite apps work, this journey will give you a clear understanding of the essential tools and strategies behind modern language technology. Let's start by looking at what NLP really is and why it's so important in today's digital world. Natural language processing, or NLP, is a field at the intersection of computer science, artificial intelligence, and linguistics. Its main goal is to enable computers to process and analyze large amounts of natural language data. NLP is everywhere from voice assistants to spam filters. By teaching machines to understand human language, NLP helps automate tasks that once required human intelligence. In this scene, we'll set the stage for the techniques that make all this possible, giving you a foundation for the more advanced methods we'll discuss next. Before any analysis can happen, raw text needs to be cleaned and prepared, a process known as text preprocessing. This involves several steps such as removing punctuation, converting all text to lowercase, and eliminating stop words like the or and. Preprocessing also includes tokenization, which splits text into individual words or sentences, and stemming or lemmatization, which reduces words to their root form. These steps ensure that the data is consistent and ready for further analysis, making them a crucial first step in any NLP project. Tokenization is one of the most fundamental techniques in NLP. It involves breaking down text into smaller units, called tokens, which can be words, sentences, or even subwords. This process allows computers to analyze text at a granular level, making it easier to perform tasks like sentiment analysis or machine translation. Tokenization is the foundation for many other NLP techniques, as it transforms unstructured text into a structured format that algorithms can work with efficiently. Stop words are common words that usually don't add much meaning to a sentence, such as is, the, or and. Removing these words helps reduce noise in the data and allows algorithms to focus on the more meaningful parts of the text. This step is especially important in tasks like text classification or search, where irrelevant words can skew results. By filtering out stop words, NLP systems can operate more efficiently and produce more accurate outcomes. Stemming and lemmatization are techniques used to reduce words to their base or root form. Stemming chops off word endings, while lemmatization uses vocabulary and grammar rules to find the correct base form. For example, running becomes run. These methods help group similar words together, making it easier for algorithms to analyze text and find patterns. They are especially useful in search engines and information retrieval systems, where variations of a word should be treated as the same concept. Part-of-speech tagging, or POS tagging, is the process of labeling each word in a sentence with its grammatical role, such as noun, verb, or adjective. This technique helps computers understand the structure and meaning of sentences, which is vital for tasks like parsing, translation, and question answering. By identifying the role of each word, NLP systems can better interpret context and relationships within the text, leading to more accurate analysis and results. Named entity recognition, or NER, is a technique that identifies and classifies key information in text, such as names of people, organizations, locations, and dates. NER is widely used in information extraction, helping systems pull out important details from large volumes of text. For example, NER can automatically find all company names in news articles or extract dates from emails. This technique is essential for organizing and making sense of unstructured data. Syntactic parsing involves analyzing the grammatical structure of sentences. It breaks down sentences into their components, such as phrases and clauses, and maps out how these parts relate to each other. Parsing is crucial for understanding complex sentences and is used in applications like machine translation and question answering. By building a tree-like structure of a sentence, NLP systems can better grasp meaning and context, leading to more accurate language understanding. Dependency parsing is a technique that focuses on the relationship between words in a sentence. Unlike syntactic parsing, which looks at overall structure, dependency parsing identifies which words depend on others. For example, in the sentence, "The cat sat on the mat," it shows how sat is the main verb and cat is the subject. This method is especially useful for understanding meaning and extracting relationships, making it a key part of many NLP systems. Word embeddings are a way to represent words as numerical vectors, capturing their meanings and relationships. Techniques like Word2Vec and GloVe map words into a high-dimensional space where similar words are close together. This allows NLP systems to understand context and semantic similarity, powering applications like search, recommendation, and sentiment analysis. Word embeddings have revolutionized NLP by enabling machines to grasp subtle differences and similarities between words. The FIDF, or term frequency inverse document frequency, is a statistical technique used to evaluate how important a word is to a document in a collection. It increases with the number of times a word appears in a document, but is offset by how common the word is across all documents. TF-IDF is widely used in information retrieval and text mining, helping systems identify the most relevant words for tasks like search and document classification. Bag of words model is a simple yet powerful technique for representing text. It treats each document as a collection of words, ignoring grammar and word order but keeping track of word frequency. This approach is often used in text classification and sentiment analysis. While it doesn't capture context, Bag of Words is easy to implement and forms the basis for more advanced models. It's a great starting point for many NLP tasks. Grams are sequences of N words used together in text analysis. For example, bigrams are pairs of words and trigrams are groups of three. Ngrams help capture context and patterns in language, making them useful for tasks like text prediction and machine translation. By analyzing common word combinations, NLP systems can better understand how language is structured and used in real-world communication. Language modeling is the process of predicting the next word in a sequence, given the previous words. It's a core technique in NLP, used in applications like autocomplete, speech recognition, and machine translation. Language models can be simple, like Ngram models, or complex, like neural networks. By learning patterns in language, these models help computers generate coherent and relevant text, making interactions with machines more natural. Sentiment analysis is a technique that determines the emotional tone behind a piece of text. It's widely used in social media monitoring, customer feedback analysis, and market research. By classifying text as positive, negative, or neutral, sentiment analysis helps businesses understand public opinion and make informed decisions. This technique combines several NLP methods, including tokenization, word embeddings, and machine learning, to accurately gauge sentiment. Text classification is the process of assigning categories or labels to text. It's used in spam detection, topic labeling, and sentiment analysis. By training algorithms on labeled data, NLP systems can automatically sort new text into predefined categories. This technique is essential for organizing large volumes of information and is a key part of many modern applications, from email filters to news aggregator. Text summarization is the technique of generating a concise summary of a longer document. There are two main approaches: extractive, which selects key sentences, and abstractive, which generates new sentences. Summarization helps users quickly grasp the main points of large texts, making it valuable for news, research, and business reports. NLP systems use a combination of parsing, classification, and language modeling to create effective summary. Machine translation is the automatic conversion of text from one language to another. Modern systems use advanced NLP techniques, including neural networks and attention mechanisms, to produce fluent and accurate translations. Machine translation is used in apps, websites, and communication tools, breaking down language barriers and connecting people worldwide. This technique combines language modeling, parsing, and word embeddings for best results. Speech recognition converts spoken language into written text. It's a complex process that involves audio processing, feature extraction, and language modeling. NLP techniques help systems understand accents, dialects, and context, making speech recognition more accurate and user-friendly. This technology powers virtual assistants, transcription services, and accessibility tools, making communication easier for everyone. Text generation is the process of creating new text based on input data. Modern NLP models, like GPT, use deep learning to generate coherent and contextually relevant sentences. Text generation is used in chatbots, content creation, and creative writing tools. By learning from vast amounts of data, these systems can mimic human writing styles and produce text that feels natural and engaging. Reference resolution is the task of determining when different words refer to the same entity in a text. For example, in Alice went to the park, she enjoyed it, the system must recognize that she refers to Alice. This technique is crucial for understanding context and maintaining coherence in tasks like summarization and question answering. Coreference resolution helps NLP systems interpret complex narratives and follow conversations more accurately. Topic modeling is a technique used to discover the underlying themes or topics in a collection of documents. Algorithms like latent Dirichlet allocation, LDA, group words in documents based on their co-occurrence patterns. Topic modeling is widely used in content recommendation, document organization, and trend analysis. It helps users and systems quickly identify the main subjects in large text datasets. Text clustering groups similar documents or sentences together based on their content. Unlike classification, clustering doesn't require labeled data. It's used in organizing search results, customer feedback, and large datasets. By finding natural groupings in text, NLP systems can help users navigate and make sense of vast amounts of information, making this technique valuable for data exploration and analysis. Information extraction is the process of automatically pulling structured information from unstructured text. This includes identifying entities, relationships, and events. Information extraction is used in news aggregation, business intelligence, and knowledge graph construction. By turning raw text into structured data, NLP systems make it easier to analyze and use information for decision-making and automation. Relation extraction identifies relationships between entities in text. For example, in Barack Obama was born in Hawaii, the system extracts the relationship between Barack Obama and Hawaii. This technique is essential for building knowledge graphs and enhancing search engines. By understanding how entities are connected, NLP systems can provide richer and more relevant information to users. Question answering systems use NLP to find precise answers to user queries from large datasets or documents. These systems combine techniques like parsing, information retrieval, and machine learning to understand questions and locate relevant information. Question answering is used in virtual assistants, search engines, and customer support, making it easier for users to get the information they need quickly and accurately. Dialogue systems or conversational agents are designed to interact with users in natural language. They use a combination of NLP techniques, including intent recognition, entity extraction, and context management, to hold meaningful conversations. Dialogue systems power chatbots, virtual assistants, and customer service bots, making digital interactions more intuitive and human-like. Intent recognition is the process of identifying the purpose behind a user's input. For example, when someone says book a flight, the system recognizes the intent to make a reservation. This technique is crucial for dialogue systems and virtual assistants, enabling them to respond appropriately to user requests. Intent recognition combines text classification, parsing, and machine learning for accurate understanding. Entity linking connects mentions of entities in text to their corresponding entries in a knowledge base. For example, linking Apple in a sentence to the company Apple Inc. This technique helps disambiguate terms and enriches text with additional information. Entity linking is used in search engines, recommendation systems, and information retrieval, making content more informative and useful. Text normalization is the process of converting text into a standard format. This includes correcting spelling errors, expanding contractions, and standardizing abbreviations. Normalization ensures consistency in the data, which is essential for accurate analysis and comparison. It's a key preprocessing step in many NLP pipelines, helping systems handle diverse and noisy text inputs. Spelling correction automatically detects and fixes typos or misspelled words in text. This technique uses dictionaries, language models, and context analysis to suggest the most likely corrections. Spelling correction improves the quality of input data and is widely used in search engines, messaging apps, and document editors, making communication smoother and more effective. Text segmentation divides text into meaningful units, such as sentences or paragraphs. This is especially important for languages without clear word boundaries like Chinese. Segmentation helps NLP systems process and analyze text more effectively, supporting tasks like translation, summarization, and information retrieval. Accurate segmentation is the foundation for many downstream NLP applications. Language detection identifies the language of a given text. This is essential for multilingual applications, enabling systems to route text to the appropriate processing pipeline. Language detection uses statistical models and language-specific features to accurately classify text, supporting global communication and content delivery. Text mining is the process of extracting valuable insights from large volumes of unstructured text. It combines NLP, machine learning, and statistical analysis to uncover patterns, trends, and relationships. Text mining is used in business intelligence, research, and social media analysis, helping organizations make data-driven decisions based on textual information. Knowledge graphs are structured representations of information, showing entities and their relationships. NLP techniques are used to build and populate these graphs from text data. Knowledge graphs power search engines, recommendation systems, and AI assistants, making information more accessible and interconnected. They are a key tool for organizing and leveraging large-scale knowledge. Semantic role labeling assigns roles to words or phrases in a sentence, such as who did what to whom. This technique helps NLP systems understand the meaning and intent behind sentences, supporting tasks like information extraction and question answering. By identifying roles like agent, action, and object, semantic role labeling adds a deeper layer of understanding to language processing. Text entailment is the task of determining whether one piece of text logically follows from another. For example, if all dogs bark and Fido is a dog, then Fido barks is entailed. This technique is important for reasoning, question answering, and information retrieval, helping systems draw logical conclusions from text. Paraphrase detection identifies whether two sentences have the same meaning, even if they use different words. This technique is used in plagiarism detection, duplicate question identification, and content matching. By comparing sentence structures and meanings, NLP systems can recognize paraphrases and improve the quality of search and recommendation results. Zero-shot learning enables NLP systems to handle tasks or categories they haven't seen during training. By leveraging general language understanding and transfer learning, these systems can make predictions about new, unseen data. Zero-shot learning is especially useful for scaling NLP applications to new domains without extensive labeled data. Transfer learning allows NLP models to leverage knowledge gained from one task and apply it to another. Pre-trained models like BERT and GPT are fine-tuned on specific tasks, reducing the need for large labeled datasets. Transfer learning has accelerated progress in NLP, making advanced techniques accessible and effective for a wide range of applications. Attention mechanisms allow NLP models to focus on the most relevant parts of input text when making predictions. This technique has revolutionized tasks like translation and summarization by enabling models to weigh the importance of different words. Attention is a key component of transformer architectures, which power state-of-the-art NLP systems today. Transformer models such as BERT and GPT have set new standards in NLP. They use self-attention mechanisms to process text in parallel, capturing complex relationships in context. Transformers are the backbone of many modern NLP applications, from chatbots to translation engines, delivering state-of-the-art performance across a wide range of tasks. Valuation metrics are used to measure the performance of NLP models. Common metrics include accuracy, precision, recall, and F1 score for classification tasks, as well as BLEU and Rouge for translation and summarization. Choosing the right metric is crucial for understanding model strengths and weaknesses, guiding improvements, and ensuring reliable results. Future of NLP is bright, with ongoing advances in deep learning, transfer learning, and multilingual models. As NLP systems become more sophisticated, they'll enable even more natural and meaningful interactions between humans and machines. From healthcare to education, NLP will continue to transform industries and improve our daily lives. Staying informed about key techniques is the first step to understanding and leveraging this exciting field.